Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 5.4, examples 1 and 2. And it can be found on pages 226 to 227. Okay, we have been working with systems of linear equations. And we know that where the lines intersect is the solution. So in a situation like this, a graph like this is one solution. And it is where the lines intersect. It's the intersection. But we're going to be talking about special systems of equations today, where our lines do this. Whoa-oh. These lines are parallel. These are parallel lines. They never intersect. Therefore, no solution. Then we have another situation where we have lines, the equations for lines, and it's the same line. Same line. All points are solutions. Therefore, this has infinite solutions. Okay, so this is a good, this is kind of a good anchor chart to hold on to. So let's take a look. The book gives us a set of equations, a system of equations. Y equals 3x plus 1. Y equals 3x minus 3. So it's kind of nice. They've already given us these lines in slope-intercept form. So we can graph these things, graph these guys. It's already in slope-intercept form, which is nice. So let's take a look at this one. My y-intercept is 1, and my slope is positive. It's going to go up, and I'm going to go up 3 over 1. Up 3 over 1. So this is the line for this equation. Now let's take a look at this equation. My y-intercept is -3. 1, 2, 3. My slope is positive. It's going to go up, and my slope is positive 3 over 1. So I'm going to go up 3 over 1. Up 3 over 1. Oh. And when I look at that, I don't know. These lines look pretty parallel to me. They are parallel lines. They never intersect. Therefore, no solution. Therefore, no solution. Okay, let's take a look at the same equations. What would this look like if we were doing substitution? Y equals 3x plus 1. Y equals 3x minus 3. So this is what it looks like when we do graphing. Let's label that graphing. And this one is substitution. Substitution. What does it look like when we use substitution? Okay, well, it's kind of nice. My y is already isolated. So I'm going to substitute all of this for my y. So I now have 3x plus 1 equals 3x minus 3. I want to get my variables to one side. I want to get the variables to one side. So I'm going to subtract 3x here. What I do, I want to get this one over here. So I'm going to subtract 3x here. What I do to one side, I must do to the other. Oh, 3x minus 3x, those guys cancel. So I have positive 1. 3x minus 3, those guys cancel. Negative 3. Does positive 1 equal negative 3? No, this is a false statement. Therefore, no solution. Okay, so what would it look like if we used elimination? What would it look like if we used elimination? Let's use elimination. What would elimination look like? Well, we have y equals 3x plus 1. Y equals 3x minus 3. And I want to eliminate one of my variables, either my y's or my x's. So I'm going to multiply this top equation. Let's get rid of these x's, this x right here. So I'm going to multiply this top equation by negative 1. Negative y equals negative 3x minus 1. And then y equals 3x minus 3. Okay, whoa, negative y and y, these guys cancel, so I'm left with 0, equals, these guys cancel, which is 0, and negative 1 plus negative 3 is negative 4. 0 equals negative 4. This is a false statement. It is not true. Therefore, no solution. So when the lines are parallel, they never intersect. So there's no solution. And I know graphing, sometimes we're given equations where graphing is not feasible. So we have to use substitution or elimination. Well, what does no solution look like for substitution or elimination? When you substitute or eliminate, you end up with false statements. Therefore, there is no solution. Okay? So let's do another example. The book has given us this system of equations. 4x plus 8y equals 36, and 12x plus 24y equals 108. And they want us to graph this. Oh, well, that's fine and dandy, but to graph these, I need them in slope-intercept form, y equals mx plus b. So let's do that. Let's put this into slope-intercept form. 4x plus 8y equals 36. I want to isolate my variable. So I'm going to subtract 4x. What I do to one side, I must do to the other. 8y equals negative 4x plus 36. I still want to isolate my y. It needs to be by itself. I'm going to divide by 8. What I do to one side, I must do to the other. Y equals negative 1/2 x plus 4 1/2. Okay, so let's go ahead and graph this bad boy. So my y-intercept is 4 1/2. 1, 2, 3, 4 1/2. My slope is negative. It's going to go down, and it's going to go down 1 over 2. Down 1 over 2. Down 1 over 2. And there's my line. But now we need to graph this line. So we need to first put it in slope-intercept form. Oops. Bring it down here. 12x plus 24y equals 108. So I need it in y equals mx plus b. I need to isolate my y. So let's subtract 12x. What we do to one side, we must do to the other. 24y equals negative 12x plus 108. I still want to isolate my y, so I'm going to divide by 24. What I do to one side, I must do to the other. Y equals negative 1/2 x plus 4 1/2. Oh, I can see this equation is exactly the same as this equation. My y-intercept is 4 1/2. My slope is negative, and I'm going to go down 1 and over 2. Down 1 and over 2. I can see they are the same line. These are the same line. That means all of these points are intersecting points. It's the same line. So all of these points are intersecting points. Therefore, this system of equations has infinite solutions. And this is, if you don't remember, this is the symbol for infinity. Infinite solutions. Okay, let's talk about what that looks like when we substitute and when we eliminate, because sometimes graphing's not feasible. So let's substitution. Let's talk about what it looks like when we use substitution. So the book has given us these equations. Okay. Substitution. I don't think this is going to be very pretty because we're looking at a lot of large numbers. But I'm going to substitute. Let's isolate x. And we'll use that for substitution. So let's get rid of 8y. What I do to one side, I must do to the other. 4x equals negative 8y plus 36. I want to isolate my x. So I'm going to divide by 4. What I do to one side, I must do to the other. X equals negative 2y plus 9. Okay, now I can take all of this and substitute it for my x. Okay, 12 times negative 2y plus 9 plus 24y equals 108. Oh, this is not pretty. Negative 24y plus 108 plus 24y equals 108. Let's combine like terms. So let's combine our like term. Hey, wait a second. Negative 24y plus 24y. They cancel each other. That's like a 0. They cancel each other. So I now have 108 equals 108. Okay, I guess I'm done because I don't have a y to substitute back into one of these equations, and 108 does equal 108. That is a true statement. Therefore, I have infinite solutions. This is what it looks like when you use substitution. Now let's take a look at what it looks like when we use elimination. So we still have the same system of equations. 4x plus 8y equals 36. 12x plus 24y equals 108. So I want to change or alter one of these equations so that I can cancel or eliminate a variable. So how about if we look at eliminating my x's? I can multiply 4 by negative 3 and it will give me negative 12x. So I should be able to eliminate those. Wow, 108. Okay. So let's push this guy over. 12x plus 24y equals 1. Wait a second. What? Negative 12x, positive 12x, those guys cancel. That's 0. Negative 24y plus 24y, they cancel. That's 0. And negative 108 plus 108 is 0. 0 equals 0. That is a true statement. Therefore, we have infinite solutions. So that's what we are doing today. So we know we've been working with one solution where the lines intersect. But there are special situations where the lines are parallel. They will never intersect, therefore there's no solution. And this is what it looks like when we use substitution and elimination. We end up with false statements, which means no solution. And then we have a situation where sometimes the equations are the same line. Sometimes the equations are the same line, in which case all of the points are the same. Therefore, we have infinite solutions. And when we look at that using substitution and elimination, we end up with a true statement. 108 equals 108. Therefore, we have infinite solutions. 0 equals 0. Therefore, we have infinite solutions.